it's going to start in a minute. Okay, so I'm just going to explain why I'm doing this. So basically, right, I've gone into the habit of just watching things whilst eating. And I don't feel like I can just go straight back into not watching and eating. So I'm going to slowly reintroduce it by watching something whilst eating, but having it be dead boring. I'm recording myself, so I know I have to do it. Because I'm not going to string myself watching something stupid. I'm not going to string myself just eating either. So I'm going to watch a paper walkthrough. So I saw online, well, I asked ChatGPT, it helps reinforce not learning, but it helps reinforce, like stop, it helps stop the forgetting curve, basically. It kind of extends the forgetting curve. Not by a lot.
Mr. Asprey, and we're going to do today NXL 2023 AS Pure. Let's do it. Let's see if we get it done in an hour, maybe even quicker. Write dy by dx in the simplest form, right? So we take the power, 3, and we multiply it by the coefficient. So 3 times 2/3 is 2. And then we drop the power down by 1. We take the power to multiply it by the coefficient, which will give me -7. Drop the power down by 1. Here is the power 1. We times that by the coefficient, that gives us -4. And drop the power down, it gives us x to the 0, so we can just not bother writing that, because that's 1. And this is 5 times x to the 0. You times the 0 by the 5, and you get 0. So any constants differentiate to 0, and that is a good job. I'll move that over here because I should have written dy by dx equals. You can get marked down for not doing good notation, so make sure you do. Hence, find the range of values for which y is decreasing. So it's decreasing if dy by dx is negative, because it means the gradient is negative, which means that the curve is going downwards. So therefore, we are looking for where 2x squared minus 7x minus 4 is less than 0. And we can factorise that. I'll use the AC method, so 2 times -4, because the A term is 2 and the C term is -4. And the B term is -7. Okay, so we write 2x all over 2, like so, and we then find two numbers that times to make -8 and add to make +7. So we get this. And the left bracket here can be divided through by the 2 on the bottom, so we get x minus 4, and we get 2x plus 1, and all of that is less than 0. So we then find the critical values for when the quadratic equals 0. In this case, x is 4, comes out of this bracket here, and over here, x equals -1/2, comes out of this bracket here. Okay, and then what we're going to do. Okay, so this is a quadratic inequality. So we're going to draw a quick sketch. We know the critical values are -1/2 and 4. We imagine that the quadratic looks something like this, and we're looking at all the points where the quadratic gives us less than 0. So that's below the axis there, and you can see that that green part is bounded in between x values of -1/2 and
kind of gives it in the question as well when it says find the range. You can't have greater than 4 and less than 1/2. It has to be in between.
4. So that is our final answer. We just underline our final answers. Beautiful. Okay, let's do it. Next question. Okay, next question. Use the substitution. U is equal to the root of x, or otherwise to solve this. Okay, so I'm going to write u is equal to the square root of x. Then I'm going to square both sides, so I get u squared is equal to x. And now we can sub both of these in. So the equation becomes 6x, we know is u squared, plus 7 root x, which is u, so 7u, minus 20 equals 0. And it's another quadratic to solve. Okay, so I'll do the same thing as before. I'll do the AC method, which is 6 times -20, which is equal to -120. The B term is 7. Because the A term is 6, I write 6, in this case u, 6u, and all divided by 6. And I then find two numbers that times together to make -120, and add together to make 7. So that will be plus 15, sorry, and -8. Yes, that does.
So what I would have done Wait. I may have forgot. Germany lost. Oh.
Oh, good. Okay, how do I divide these two by 6? Well, I can divide the one on the left by 3, like so, and I can divide the one on the right by 2. And overall, I've divided the whole thing by 6. Okay, great. So I can now write this over here on this line of working. And that tells me that u is equal to minus 5 over 2 by solving that mini bracket here. And solving this bracket gives me u is equal to 4 over 3. I can then replace by saying root.
I completely forgot. I'm going to mute myself because no one wants to hear me eating chicken.
Is equal to minus 5 over 2 and root x is equal to 4 over 3. Okay, so a few things to note here. This one cannot work because the square root of x is always positive. I know some people think that's not the case because when you square root a number you get like a plus or minus, but that's only if you square root part of an equation. If you just have something defined as the square root of x, and that is always going to be a positive value. You might put plus or minus in front of the square root, but the actual square root of something is always a positive value. So that part does not work. This one is all good. That's fine. So we can find the value of x by squaring both sides, which is going to give me 16 over 9. So that is the only correct answer. Beautiful. Okay, question 3, and we have a sketch of the positions of 3 phone masks. Okay, blah, 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 blah. And we know that mask A, so we're going to put this on the diagram, is 8.2 away. So from C, this is 8.2. And we also know this angle in here is 72 because bearings are always measured from north and they're measured clockwise around. Mask B, I'd have to draw another line from C connecting up to mask B, and that is 15.6, and that is on a bearing of 39 degrees. So this angle in here, let's do a different colour. That red angle is 39 degrees. Find the distance between masks A and B, giving your answer to 1 decimal place. Okay, so we need to find this distance in here. I'll call it x. And we can also work out what this green angle is here, because it will be the blue angle of 72 minus the 39 angle, the red one. So that will be 33. Okay, so we can use the cosine rule to solve this. So I'll just scroll down here. And the cosine rule is that cosine rule to solve this. So I'll just scroll down here. And the cosine rule is that x squared is equal to the two sides adjacent to the angle, which were 15.6 and 8. Just double check. Sorry, 8.2. Yep. Okay, so 8.2 squared minus 2 lots of 15.6 times 8.2 multiplied by the cosine of the angle, which we said was 33. Okay, so I'll get a value for x squared. I'll do that on my calculator now. Okay, I've just put that into my calculator, being careful to make sure that my calculator is in degree mode, and I've got 96.0. So then to find that actual distance, I need to square root the answer. So therefore I get 9.80. It's just a 1 decimal place, so that's just 9.8. Great, so I can underline that, give that a tick, and that is for part A. Lovely, and then it says an engineer needs to travel from mask A to B. Give a reason why the answer to part A is unlikely to be an accurate value of the distance the engineer travels? It's because he's unlikely to be able to travel in a straight line. That's just a straight line from direct, like as the crow flies, I think it's the term. But because this is quite a big distance, it's kilometres, he's going to travel by car, so the roads aren't going to be exactly a straight line. So you could just say it is unlikely the engineer will travel in a straight line. In a straight line. As, does it say he or she? No. So as they will likely use roads. I think that should do the job. Okay, question 4. We're sketching a curve, and that happens to be a reciprocal graph because it's a number, a constant, over x. Now, they all look the same regardless of what the constant is, unless it's positive or negative, that's when it will change. But if it's positive, then it's going to be really close to the y-axis when x is small. It's going to arc down like this, and then it's going to be really close to the x-axis when x is large. So it's going to come down like this, and then it's going to constant, and it's always going to be decreasing on that side. And then over here, it's going to look like this. So it's going to be almost like a mirror image. But this one is in the negative quadrant, the third quadrant. So that's y and that's x, and then I'll just label it to say that is y is equal to k over x. It doesn't really matter what k is, it can be 1, 2, 3, 4, 5, they're always going to look the same, and because they're not intersecting with any of the axes, we don't need to label any particular points, so it doesn't actually matter what k is. Okay, right, part B. This is interesting, this question, because it says hence or otherwise, and in fact, I'm going to show you both ways to solve it. So let's first solve it using hence, which means using the part previous, so part A. So we have already, we've got this graph kind of drawn for us. It's the purple line. It's just when k is 16. So let's draw the other side of the inequality, which is going to be 2. So y equals 2. And I will draw that in green. So it'll just be a horizontal line coming across like this. Okay, so the question is asking me, really, when is the purple line, so the purple line, when is it below, less than, the green line? Well, we can see from the graph that happens here, so all these x values to the right of this intersection point, and it also happens over here as well, like that. Okay, so what is that intersection point where the two meet? So that it will be where 16 over x is equal to 2, so 16 is equal to 2x, so 8 is equal to x. So that happens here at when x is equal to 8. So you can just see from the graph here that that x is greater than or equal to 8 is going to satisfy this inequality. And then we do union because there's another section which is not connected which also satisfies the inequality. It's this part over here. And this is just any x value which is less than 0. We've got 0 here, so any x value to the left. So x is less than 0, and it can't equal 0, of course, because we can see here that x will never equal 0. So that is the answer, just by looking at the graph and solving for intersection points. If you wanted to solve that without the graph, then what you could do is you could multiply both sides of this equation by x squared. And you have to do it by x squared, because when you are algebraically solving an inequality like this, you can't multiply through by x, because you don't know whether x is positive or negative. And if you multiply through by negative, it changes the sign around. So just multiply through by x, we won't know whether to change the sign or not. But multiplying by x squared, we do know whether to change the sign. Well, we don't change the sign because x squared is positive, always. So if I do multiply through by x squared, I get this. I can rearrange this, like so, just to get it into a quadratic. I can then take out a factor of 2x, like so. And this tells me that x equals 0 is one of the solutions, and from here, x equals 8 is the other solution. Now, whenever you do a quadratic inequality, what you want to do is you're going to want to just draw a quick sketch of the quadratic, looks like this. And we're looking for where that quadratic is greater than 0. So that is when it is above the x-axis, like that. And you can see here that it's exactly the same answer as the one we've got previous. It's where x is greater than or equal to 8, so this part, or when x is less than 0, this part. Perfect. Okay, we've got a lovely.
Mm. The thing is, I've done that question so many times, and I think I've gotten full marks every time. So I just use my CG50 calculator. I figure out a way. I never knew that, and I've just learned both ways. It's pretty cool. Because the reason why I'm doing this, right, is because if I spend my actual time sitting down, I'm either gonna take questions that take a long time but blast through them, and then just end up spending like 10, 15 minutes on a question that I'm stuck. If I can just go, like, just learn how to do it, I don't know. I think it's just easier to do this.
And we've got a region which has been boxed off. So we've got to find the exact value of r. We've got to find the region basically. Okay, fine. So what we're going to do is we'll draw a line down here, like so, and we're going to find the x value which corresponds to the curve having a y value of 23. So we're going to say y equals 23 at this particular point here. Let's call this point P. So we can say that 23 is equal to 4x squared plus 3, like this. So set that equal to 0. So 4x squared, actually that's not the best way of solving it, sorry. Subtract 3 from both sides. Divide through by 4. So we get x is equal to plus minus root 5. But we can clearly see from the graph that the point P we're looking for is a positive x value. So we're going to call that value there root 5. Okay, lovely. So how does that help? Well, that helps because now if I integrate between root 5 and 0, I get the area which is bounded by the curve, the lines 0 and root 5, and the x-axis. So if I integrate now, I'm going to get this blue area. Let's call it B because it's blue. So B is equal to the integral between root 5 and 0 of this curve, which is 4x squared plus 3. Need to put that in brackets and then multiply it by dx to show that we're differentiating the whole thing. So we're integrating the whole thing with respect to x. Okay, now let's integrate. So we up the power to a 3, and then we divide by the new power, like so. And here we up the power to a 1, so it's 3x to the 1. Divide by 1. Well, there's no point in dividing by 1. It's not going to do anything. So, bosh. That's it. Okay. So now we need to input our root 5. So root 5 cubed is root 5 times root 5 times root 5, which is 5 root 5, times by 4 is 20 root 5, so it's 20 over 3 root 5, plus 3 root 5. And then when I take away, when I sub in 0, well, that's just going to be 0. Okay, great. So how many root 5s we've got here? We've got 20 over 3 plus 3 is the same as 29 over 3. Of course, you can use a calculator like this, or you can just do a non-calculator like a boss. It's up to you. Okay, so that is the area of the blue bit, but it's not what we're looking for. We're looking for the grey bit. So we need to take this blue bit away from the rectangle, and you can see what the area of the rectangle is, because it's going to be have a width of root 5, and it's going to have a height of 23. So we can say that r is equal to 23 multiplied by root 5 minus the blue bit, which is 29 over 3 root 5. So that is just simply 23 root 5 minus 29 over 3 root 5, which is the same as 69 over 3 root 5 minus 29 over 3 root 5, which gives us 40 over 3 root 5. And it says show that the area is equal to this where k is a rational constant to be found. So I can just finish off by just saying that k is equal to 40 over 3. And that is job done. Beautiful. Okay, classic AS Pure question this. You've got a circle and you've got the equation, but it's not in the nice complete into square form, and it's asking you to find the centre. So we're going to complete the square. We're going to look at the x's, and we're going to write them out next to each other. So x squared minus 6x. And then we're going to look at the y's, and we're going to write them out next to each other like this. So plus y squared plus 10y. And then we're going to move the k to the other side. Okay, let's complete the square. So to complete the square, we always look at the b term, so the term number of x's, and we halve that number. So we do minus 6 over 2, which is minus 3. And that number is important because that goes inside the bracket. And then we also need to take away that number squared. Okay, let's do the same for the y. Well, what's the y beta? Whoopsie. I don't know why I put a squared there. Apologies. So that's 10y. So we can take 10, we can half it, we get 5. So it becomes y plus 5 all squared minus 5 squared. Okay, so that's just classic completing the square. Hopefully that's okay. And that gives us minus 25. And then we bring the those constant terms over to this side. So minus 9 minus 25 is plus 34. That's what I add it over it is, sorry. So we get this. Yep, that looks good. So what's the centre after all of that? Well, the centre are the x values, or the x value that solves this bracket, that makes that bracket 0, so it's 3, and the y value that solves this bracket, which is minus 5. Okay, part B, find the range of possible values for k. Okay, so the first thing I'll do is I'll draw a sketch. And we can see that the centre of the circle is going to be somewhere like here. So that's 3 minus 5. So let's draw the biggest possible circle we could have. Well, it might look something like that, actually. Now, that one actually does touch the x-axis, but let's just leave it like that, yeah? Let's have it there, touching the x-axis, because we know it can't be any bigger than that. That's the absolute maximum. In fact, that's even not allowed, because it says it's not allowed to touch. But let's just imagine what would happen here. Well, what would this radius be? Well, it'd be 5, because it goes from minus 5 in the y up to the x-axis, where y is 0. So that would have a radius of 5. Now we know that we're not allowed to have that bigger radius, because it's not allowed to touch the x-axis. So 5, it has to be less than 5, the radius. But also the radius has to be non-zero, because it has to be, I mean, a circle has to have a radius, doesn't it? So the radius, we know, is the square root of this side of the equation when it's written into completed the square form. Okay, so there's two conditions. The radius cannot be 5 or more, and also the radius must be non-zero. So it must be greater, or yeah, it can't be 0, so it has to be greater than 0. Obviously it can't be negative either. Okay, so if we square both sides of this inequality, we get 25, and if we square both sides of this inequality, we still get 0. Then if I take away 34 from this, I get minus 9, and if I take away 34 from this, I get, what do I get? I get minus 34. Then if I divide through by minus 1, that swaps the sign over, which is critical to remember on equality. Okay, so both of these things have to but again, it can't be more than 5, and it can't be non-zero. So we have to conclude these together. So k needs to be greater than 9, and it has to be less than 34. So as a single inequality, we can say that k needs to be greater than 9 and less than 34. And that is Bosch. Beautiful. Okay, question 7. I've actually coming back. I've actually done the whole paper. I'll come back to this one because I couldn't face doing it because it just looks absolutely horrendous. Right, so let's actually do it now. You've got a car travelling, great. You've got 40 litres left if you've done 80 kilometres travelled, and you've got 25 left if you've done 200 metres. It says using a linear model. Okay, so a linear model means that it's a straight line, so it's y equals mx plus c. And we've got different variables. Obviously, we don't have y and x. We've got variables v and d. So you can make either of them the y or the x. I don't think it actually matters. Well, it doesn't matter. I'm just going to pick v is equal to the y, and d is equal to the x, just because it's in that order. So it kind of makes sense, I guess. Okay, and therefore, if I write it like this, xy and xy, I won't make a mistake. Hopefully not. So we've got 40 litres, so that's the v, which is the y. And we've got 80 kilometres, which is the d, which is the x. So that's one bit of information written as a coordinate. And then here we've got 25 litres, which is the y. And 200, which is the distance, which is the x, so 200. Okay, fine. So in order for us to find the m now, let me just get a bit of space. Yeah, in order for us to find the m in this equation, remember m is the change in the y over the change in the x. But in this case, that's the change in the v over the change in the d. So the change in the v, which is actually the y, is 25 minus 40. And the change in the x, or the d, is 200 minus 80. Okay, fine, I think I've done this, brilliant. Okay, so minus 15 on top, 120 on bottom. This simplifies to minus 1 over 8. So that's the gradient. Now if I want this as a equation, now I also need the c, don't I, the intercept. So I've got v is equal to minus an eighth d, and that is plus c. Okay, so just to reiterate, this is the d, that's v, this is d, that's v. Yes, fine. So let's use the 25 200 one. You can use either. So if it was 25 200, it'll be 25 as the v multiplied by 200 plus c. 200 divided by 8 is 25, isn't it? So that's minus 25 plus c. So the c term is equal to 50. So our equation is now actually v is equal to minus 1/8 d plus 50. Bosh. Okay. It says, given that on a particular journey, the fuel tank of the car was initially full, the car continued until it ran out of fuel. That's a very silly thing to do. Find according to the model, the initial volume of fuel that was in the car. Okay, so we can do that because we've got this formula now, haven't we? So if the volume, so part B, the initial volume of fuel would be what happens when the distance travelled is 0. So V will equal 50. Bosh. The distance that the car has travelled on this journey. Well, it said that it ran out of fuel, didn't it? So it's not going to travel any more after it's run out of fuel. So the velocity, the tank, V is the amount of the fuel. So that's equal to 0. So that implies that 0 is equal to minus an eighth d plus 50 times both sides by 8 gives us this. No, it doesn't. It gives us 400. So that means the distance travelled is 400. Now I need to be careful here because I've not used units. So just to check. The units are litres and kilometres. So I should really write in here litres and here kilometres. For any modelling question, please give your units. Don't lose marks over units. It's not worth it. In fact, the car travelled 320 kilometres on this journey. Evaluate the model in light of this information. Well, that's no good, isn't it? Because that's a significant difference, isn't it? Because you could do 400 minus 320 over 320 times by 100 to get the percentage error. So 400 minus 320 divided by 320 times by 100. So that's an error margin of 25%, which is rubbish. That means the model's not good. So you can write the model is not reliable as the error is 25%. Okay, job done. Okay, so this question, it says that figure 3 shows a sketch of a curve and a straight line. Given that C has the equation y equals fx, where f of x is a quadratic expression, and C cuts the x-axis at 0 and 6, and then it also cuts the line cuts the y-axis at 60 and at the point 1080. Okay, so first off, what we're going to need is to find the equation of the quadratic. Now, what we do know is we know the roots of the quadratic, which is useful because we can write it in factorised form. So we could write y is equal to x, well, x minus 0, so that's just x, and x minus 6. So this would work. This would be a quadratic which has roots at 0 and 6. But it's not the only quadratic that has roots at 0 and 6, because you can stretch a quadratic up by multiplying it by a certain value. So let's call it a. So we don't know exactly what we could actually multiply it by, but we do have a point which is on the quadratic. So that is going to give us enough information to be able to substitute in and then work out what the a value is. So I'm just subbing in that point 1080 because I know it's on the curve. So this is going to give me 80 is equal to a multiplied by 40. So we can see here that a is equal to 2. So that's great. That means that I know for certain now what that quadratic is.
saying, I'm just going. He used to post good videos. Now he's posting so much. Like, look, 20 minutes. So 3 times in one day. 5. 5 times in one day, and it's all about the same thing. Look, Apple, Nvidia, Pinterest, Apple, 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 Nvidia, Pinterest. Nvidia, Nvidia. So these guys are just posting too much. Like, I don't believe. And what's up with his thumbnails as well? I'm sorry, I'm just going off on one. Okay, that's actually a pretty decent AI image. So no offense, also I don't even have. I'm flipping struggling. This video is actually great. I actually love this video. I thought that was a great video we did. But obviously people don't care about that. They want. Look, these images are good. What's up with this image? Why is it so blushed over? So, look, this. No one's skin looks like that. That's like a real body. That's not blushed. That's normal. It looks kind of not. But that, why is it so fake? Bro, it doesn't look real. It looks drawn. Anyway, the guy's an MAD and a PhD. But I don't think he's actually finished his MD thing. But that's still sick, MD, PhD. Anyway, yeah. Also, if I watch normal YouTube, I get in the habit of not doing it after work. Gratical. Sorry, I'm just curious.
Now cut into smaller pieces and set aside. After doing that, in a large skillet over medium to low heat, add a drizzle of olive oil, a small onion chopped into cubes, a medium grated carrot, a grated zucchini. Start by placing 800 grams of beef liver in a Ziploc bag. Then, place it in the microwave and cook it on high power for 7 minutes. It should look like this. Now, cut into smaller pieces and
I might start microwaving chicken. Sorry guys, I just wanted to look into the possible future. That's kind of sick. PhD, MD. What's kind of annoying though, I know it's not annoying, but like A's and B's kind of easy at A level, man. And they just go ahead and do it. It's to connect. Yeah, midpoint. Yeah. Okay, I'll stop that there, and then I'll come back. Message Ryan, see what he's playing at. Actually, I still got to go traveling to buy some stuff. Actually, let's put my MacBook on charge. And yeah, we still got some good time for the day.